This is our first lesson on inverse functions. We're trying to answer two questions. What is an inverse function? And how can I figure out if two functions are the inverse of each other? So what I'm going to do before we even talk about inverse functions, let's sort of review inverse operations. If I had an equation, the third root of x minus 5 plus 4 is equal to 6, and I told you to solve that for x, what you would be wanting to do would be to finally, at some point, have an x on one side, something else on the other side, which doesn't have an x in it, and then the equation is solved. One way of solving equations for x is to isolate the x by using a series of inverse operations. Inverse operation is what you do to get rid of everything that you don't want there. So here, the first thing I'll say is, well, I don't want to have a plus 4. So the inverse of plus 4 is minus 4. I do a minus 4 to each side of the equation so that I have the third root of x minus 5 is equal to 2. I'm a little closer to having the x all by itself. Now what I want to get rid of is the third root. So in order to get rid of the third root, I raise both sides to the power of 3, because the power of 3 is the inverse operation of the third root. So now the power of 3 undoes the root of 3, and I have x minus 5 on the left side and 8 on the right side. My final inverse operation is to do a plus 5 to both sides of the equation, and I end up with x is equal to 13. This also works when I'm working with the kind of equation that's called, I always forget the name, but it's kind of equation where you end up with something ugly with letters in it on the right side instead of a plain number. So for example, suppose again I say solve for x. I have almost exactly the same equation. Third root of x minus 5 plus 4 is equal to y this time. I can still solve that for x. I won't get a nice number as the answer, but I'll still get a solution. So again, the first of what I want to do is a series of inverse operations. So I'll subtract 4 from both sides first, just like I did before. And I get the third root of x minus 5 is equal to y minus 4. Now I can raise both sides to the power of 3. And on the left side I have x minus 5. On the right side I have y minus 4 to the power of 3. Then I add 5 to both sides. I end up with x is equal to y minus 4 to power of 3 plus 5. I used a series of inverse operations, again, to solve for x. Now, let's talk about what an inverse function is. So if an inverse operation undoes another operation, an inverse function undoes another function. For example, what do you mean by undoing a function? Well, it's slightly more complicated than undoing an operation, but not terribly. So suppose we have two functions. One of them is f of x is equal to the third root of x minus 5 plus 4. And the other function is g of x, which is equal to x minus 4 to the third power plus 5. If I take the composition of these two functions, f of g of x, and the functions really are inverses, when I simplify, I get x. I also should be able to take the composition in the other direction, g of f of x, and get x. If both of those are true, that means one function undoes the other function, and they are actually inverse functions. So let's actually do that. F of g of x would be f of the g of x function. The g of x function is x minus 4 to the power of 3 plus 5. So then I'm going to rewrite my f function. Here's the f function. The f function says you take the third root of the input, subtract 5, then outside of the radical you add a 4. See, that is the f function. Well, this time my input is x minus 4 to the third plus 5. Okay, well, you don't really need those parentheses, do you? This is the same as the third root of x minus 4 to the third plus 5 minus 5. So this plus 5 undoes that minus 5. We now have, well, we still have the plus 4. So we have the third root of x minus 4 to the power of 3 plus 4. Well, how about that? The third root undoes the power of 3. We've got x minus 4 plus, stop it. X minus 4 plus 4, which of course gives us that x. So when we do the composition of this function, f of x, with this function, g of x, we end up with x. That means that g of x is the inverse of, and one way to write that is with a little -1 there, the inverse of f of x. That's it for the first one.